we are here on number 6. So number 6, it says for each of the following functions, describe their average rate of change over the given interval as positive, negative. Try to do this without substituting values, okay? So when we're doing this without substituting values, what we're talking about is graphing. So creating a graph and estimating and seeing what's happening to the slopes. Does that make sense? So we're going to create the graph of x squared. So last year we focused on all of our parent functions. You all remember all the functions we learned in Algebra 2? Maybe, maybe not. But we learned all of them. And so, you too. We're going to have to remember those functions. You got to know what the quadratic function looks like. You need to know what your log function looks like. You need to know what your rational function looks like, okay? These are things that you should have left Algebra 2 at least being able to identify, okay? All right, so first up, what do we have? We have a quadratic. Agreed? So we're going to draw the quadratic parent function. Yes. Sorry. Remember, I'm trying to make our paper last. All right, so there's our quadratic parent function. The interval that we're looking at is from 2 to 3. So from 2 to 3 is what we're analyzing. So from 2 to 3, what is it doing here? Increasing. So what does that mean the average rate of change is doing? Is it positive or negative? It is positive. Now, was that terrible?
Absolutely. Oh, is that all?
That's it.
Wait, so that's what the answer is?
The answer is positive. The graph showing that this is what it means without substituting in the values. They want you to tell me on this interval, is the average rate of change going to be positive or negative? Okay. So on your do now today, I had you reading some convoluted little words, right? And you had to determine whether it was going to be positive or negative situations, right? Now we're going to be looking at the graphs to do the same thing. All right, up next, what function is this? Logarithmic. Logarithmic. I feel that's spelled correctly. Logarithmic.
I spelled it the same way you did.
Good job. We did good. Okay, so we're going to draw a sketch of the log function. Now, log function has a special characteristic. What is it? Anyone remembers?
It goes like this. I don't even know.
It doesn't touch 0. It has an asymptote at 0. Do we remember that? The log function has an asymptote at 0. So it gets close to 0, but it does not touch 0. Okay, our log function is going to go through 1, 0. And then it keeps going, right? Okay, but because of that vertical asymptote, yes, vertical dash. Vertical dash. All right. And so it says from 0.01 to 1. So from 0.01, which is real tiny right here, as close as possible to 0, but we're not actually at 0. So from this point all the way down here up to here, what is my slope doing?
Negative.
You read from left to right, so it's positive. We read the graphs from left to right. So when I'm reading from left to right, to get from here to here, it's doing what? It's going up, it's increasing. So we have a positive average rate of change. Sorry, I didn't write average rate over there either.
Okay, so.
Okay. All right. What is C? What type of function?
Can we just see if it's positive, if it just,
Yes.
is going upwards in the numbers? Oh, wait. No, never mind.
You can't. This is an exponential. Why is it exponential? The x is your power. We see that guy? Makes us exponential. All right, so we're going to draw a little sketchy sketch here. What makes exponentials special? That's rational. It's rational. It's a curve and it has an asymptote, but this time the asymptote is, and it does increase fast, but this asymptote is horizontal. Remember, exponentials and logs are inverses of each other. Logs have vertical asymptotes and exponentials have horizontal asymptote. So this time our asymptote is on the x-axis. We're gonna get as close as we can to the x, but do we touch it? No, because there's an invisible boundary that says, ha ha ha, you can't come here. All right, so when we draw it, it's going like this. And why is this one declining? Because it's getting smaller. It's the half because of the fraction. I'm declining because I'm a fraction. I'm a half. So it's going to be I'm cutting in half repeatedly. Every day using half of your money. Imagine that.
Really?
That's why it looks like. What's wrong with you? Okay, so on this interval, it's going to be what? Why is it negative? It's declining, so it has a negative average rate of change. Negative AROC. Okay, on the given interval from -1 to from here to here, right? We're going all right, and then back to what again? A quadratic, but this time we have a what kind of quadratic? A negative quadratic. We have a negative quadratic. How do we know it's negative? My pen is doing weird things. That's 1t combined. It looks like it's 2, but it's not. It's negative because our leading coefficient is negative. Agree? Okay. So it's doing this.
So we wouldn't even have to graph that to know it. Well, you could be on the side of it.
You can be on the side. All I know is that I have to be negative and I have to go through 5. As long as I'm negative and going through 5, my sketch is good enough. So
the first one was like a negative, but it was like the power like that. So would it be negative x squared?
say that again.
Or a? Like what would it look like if that kind of
If it was this one,
yeah, would it be negative x squared for it to be negative?
yeah, in order for it to be down,
Yeah.
yes,
Or would it be x? Okay.
it'll be negative x squared. All right, so here from 1 to 4, regardless, what's happening? It's declining, right? So I would have a negative AROC. How do we feel about graphically identifying negative and positive average rate of change? Good? Doable? All right, moving on. Moving on. All right, up next, it says, we're going to let R of T be the altitude of a rocket seconds after launch. Write an expression for the average velocity of the rocket from the time T equals 5 to T equals 5 plus H. Oh no, it's not just numbers, but it's a number and a variable as my interval. Do we see that? So my interval is now from 5, comma, to 5 plus H. That's my interval. Okay. And then I need to find the Y values for this. Well, in order to find the Y values, I would do what here? If I knew R of T, I would substitute it in, right? But do we know what R of T is? No. So all we can write it as is R of 5. I can't go any further because I don't have anything to plug this into. Same thing here. I don't know what R of T is. I do not know what H is. So all I can do is substitute it in for T. It's replacing my T. So now you clearly have your X1 and your Y1, your X2 and your Y2. Can I find AROC with what I have? Because AROC is the change in my Y over the change in my X. So my y2 is r of 5 plus h minus my y1, which is r of 5 all over my x2, 5 plus h minus my x1, which is 5.
On the bottom line, we are from 5 to.
Yeah, it's just whatever your x1 and your x2 are. Okay? Now, if you left it like this, you would get only partial credit. Can anyone guess why you'd only get partial credit? You can simplify the denominator, right? 5 plus h minus 5. It would just be h. Why would it just be h? Because the 5s cancel out. So all you're left with is your h. That would be the final answer. You can't distribute because this isn't a distribution. This is a function notation. So until I have a function, I can't do anything else.
So would it be 5 plus 8 dividing R5 over H?
Just over h, exactly. So 5, I forgot my r. R 5 plus h minus r of 5 all over h. And that would be your final answer, your simplified answer. If it bothers you not to cross it all out.
So the spots on the bottom don't cross out the ones on the bottom?
No, you can't eliminate through addition and subtraction, only through multiplication and division. Okay. So this is an example of you only can do as much as you're given to do. Okay, you don't make up an R of T to plug things in. You don't make up an H value. You only do what you are given to do. Does that make sense? If they don't tell me what R of T is, I can't plug anything in. If they didn't tell me what H is, I can't plug anything in. Okay, don't make it more than what it is. All right. On 8. I need a graph. Where's my graph? I don't know. We'll figure it out. All right. It says here, given y equals x squared minus 2x plus 3, find the average rate of change of the function on the following intervals. At this point, we can all do that, right? We can all confidently find from -1 to 1 and 1 to 3. If I'm given the function, I got to find the values. Yes? So if I go a little quickly through that, no one's going to be like, Miss, how'd you do that? You sure? We're good? Okay, here we go. So when I'm plugging this in, I'm plugging in +1 first. Agreed? Because this is my x1 and my x2. And I need to find y2 first, correct?
Yeah.
So I'm going to plug in 1. So I get 1 squared is 1. 1 times 2 is times -2 is -2. So 1 minus 2 is -1 plus 3 is 2. So my first y value is 2. My first one that I'm writing down. Yes, y2 is 2. Okay, now we're gonna do the same thing with the -1. A -1 squared becomes a what? A +1, right? -2 times -1 is +2. So now we have 1 plus 2 is 3 plus 3 is 6. And that's my y1. My x2 is 1. My x1 is -1. So we end up with -4 over 2, which equals -2. As you keep doing this, your work gets a little bit less for some things, right? Does that make sense? I don't know what Pandora be doing. She tries to make me like things. Just gonna ignore Pandora right now. Don't pay her any attention. Don't feed into it. All right. Don't feed into it. Here we go. X2. So it's our X2 is 3. So we're gonna find our Y2. What is 3 squared? 9. What is -2 times 3? -6. 9 minus 6 is 3 plus 3 is 6. Good job, guys. All right, next one. 1 squared is 1. -2 times 1 is? -2. So 1 minus 2 is?
One.
-1. -1 plus 3 is? 2.
Yeah.
Shh, just go with it. Just go with it. And we end up with this time a +2. Yes. All right, so you should have your graph. I don't know where my graph is. Is your?
The graph needs to count the bit.
Yeah, that's what our next model was supposed to be, but my graph isn't up here. I don't know why mine didn't print on my thing. All right, so you should have a graph on yours, right? And on your graph, do you see that you can count from one to the other? Like literally doing rise over run. If you're given the graph, guess what? You can rise over run. That's a basic skill that you learn in Algebra 1, right? Okay. I don't know where my graph is. I'm really depressed about not having my graph, but do I need a model rise over run, or are we okay? We're good? Because I don't have a graph. But yes, so you can easily draw your slopes and draw a line and count the slopes. Okay. If you're given the graph from one X to the other X. Make sense? All right. And if I need to do it more, I will, but I just realized my thingy deleted somehow. Did I put it on another page? Nope, it's just gone. All right. So describe the relationship between the rate of change and the behavior of the function. So when you look on your graph from -1 to 1, notice, what do you notice about your function? What is the line doing if you were to connect them? Well, no, the line, if you were to connect from -1, what is the line doing? It decreases, right? So that decrease lets us know that our AROC is going to be what? Our rate is going to be less than 0. Our rate is going to be negative. Is that what happened? Yes. Okay. When you look on the interval from 1 to 3, what kind of line did it create? A positive, an increasing line, right? And because it's positive increasing, we knew that our rate was going to be positive, greater than 0. And was our rate greater than 0? Yes. Now, what if it's just asking for the rate at a specific point? What do you think I could do? Because at 1, it changes, alters, right? At 1, on one side of it, it's a negative, and on the other side of it, it's a positive. So it's asking us, what does that mean? Well, that means at x equals 1, the function has a minimum. And guess what the rate is specifically at 0? And the rate is 0. When this happens, we call that a turning point. So x equals 1 is a turning point. Because it's the turning point. That's when one side of the graph slopes go from decreasing to increasing, or vice versa. That's why it's a turning point. Your turning points are going to happen at your maximum minimum places of concavity. Does that make sense? Because that's typically where you are changing directions, unless it's piecewise. This is a long song. All right. Yes, no, maybe so. Yeah. Do we understand why, again, 1 is a turning point? Yeah. All right. Because when you use 1 in 2 different situations, it created 2 different types of slopes, right? On 1? Yes. Like if you're saying where it's increasing and decreasing, because it's going to be increasing on this side, but it'll be, so you would still use your markers. All right. Pandora apparently wants us all to wake up. So, all right, here we go. A remote control control car travels at a distance of S of t equals 10 squared feet in first t seconds after it starts. Calculate the average velocity of the car on the intervals shown in the table below, okay? I actually want you to use a calculator for this, so you can use your calculator. Sure, you can use your calculator on your computer, or you can use this, but, huh? I would if I was you. I was like, I would, but if you don't want to, yeah, in a moment. Just so that you can get the values a little faster. And you're gonna calculate the average rate between the two, right? So we're at 1.99 to 2, 1.999, 2. And you're just gonna find those values and find the difference between those two values, then find your AROC. What's going to take you long is just finding the values and going from there. And then we're going to talk about what pattern do you see is happening. Mm-hmm. Huh?
You can't use the graph to look at the rate of change.
It's not going to tell you the value. The graph will tell you whether it's positive or negative, but it's not going to tell you what it is. Let me grab my calculator. Wake up, Sylvie. So, for example, if I have a lot of points and I'm trying to find their values, you can second trick. Are you talking about the values? Yes. So, I'm going to plot 10x. That's not an x. X squared, right?
Yeah.
I can go to the graph. And it's like going to show me this. While you're at the graph, you can do second trace and turn on values. And that allows you to type in whatever value you want. Okay. And that'll give you an output. That's option 1. Okay. I can type in 2 now. It's going to tell me here's the value of 2. Here's the value of 1.999. Okay. Your other option is to go to table settings and change your table settings from auto to ask. And you turn your table from auto to ask, it's now going to take you to the table and you'll have a blank table and you can put in whatever you want. So if I need 1.99, there's 1.99. If I need 1.999, there's 1.999. If I need 2, here's 2. I need the value of, so you're going to press second window, table set, and you can go from auto to ask.
For the
From the independent. For the independent, you're going to auto, from auto to ask. And now, okay, so you're going to go second window, and you're going to switch it from your independent variable from auto to ask by pressing enter. Now, when you go back to the table, you can put in the values that you want. So second window.
what?
Okay, so now I have all of the y values that I need. Does that make sense?
Yeah.
From auto to ask.
For both. Where do you go after you?
Then you go back to the table. So second graph. And you should be able to go back there. And then, yes. So first thing I did was graph my equation, guys. Step 1 was to go to y equals. I didn't know I have to tell you this step, but you have to put the function in or it doesn't know what it's calculating. That's thing number 1. So now we talked about you either can go to the graph and use use trace feature and type and find the values from here, right? I can find the value of 1.99. No, I didn't change anything in that setting. I just graphed it. So this is the y value for that, right? I can type in 2. This is the Y value for this guy. Okay, so that's option 1 is doing it from the graph. Option 2 was to go to second window, change your independent from auto to ask. Then you can go to the table and type them all in at once and get your values. So my 1.99 is 39.96. We already know the value of 2 is 40. This is 39.96. This guy came out to be 40.04. This is 40. And all I'm doing is saying, what are the Y values that correspond? Because can you find the average rate of change without the Y? And the answer is no.
I changed it, but I have to put the L2 myself.
You weren't supposed to put anything in a table. We didn't go to table at all.
I don't think you're not plotting points, you're like putting in equation. Oh, so then whenever, but if I had done that, would I put, how would I got into that table?
I'm gonna have to come specifically to see what you mean, ma'am.
Are you trying to get to the table after you cut it in your equation?
Second,
Well, I asked, like, if I had it done real quick-
second trace. And so you go second trace, then 1. You were looking for the trace the entire time? And the words of my grandma, if it was a snake, it would have bit you. So all you're doing is subtracting now. So once you did your AROC, you should have ended up with 39.9, 39.99, 40. 41.
Numbers also Y values. I mean, are all X values. You put in on these, you put also Y. You put in all these numbers, like this number.
So based on what's happening here, as you can see, it says, based on our calculations, you can approximate the exact velocity of the car at 2 seconds after it starts. So when I'm trying to find the average rate of change at a specific point, I'm going to analyze what's happening as I get closer and closer and closer to that point. So when I look here, what's happening as I come from the left and I come from the right of that point? What is it approaching? 40. So what is the average rate, the exact velocity at 2 seconds? 40, right? So the velocity at t equals 2 seconds is approximately 40 feet per second.
Well, you know what?
Wait, so is this calculus or is this still algebra?
We're in pre-calc.
Yeah, I know, so we're done with the algebra.
Mhm.
Wait, is there a pre-cal test or is it just AP calculus?
It's AP pre-calculus, the actual AP pre-calculus.
But it's like the first reading.
Mhm.
Okay, United States.
Yes.
This
Yes.
is why the district won't make it active. That's why I was like looking at the actually really what, and I was like,